Alright guys, so what we're going to be talking about here is we're going to head in a completely different direction from what we were talking about before. Where we're going to be talking now about something that's, some of you may have seen it a little bit before, but it definitely is a different and new idea. Not difficult, but definitely new. We've looked at the first couple things, at least you should have back when you were a sophomore. Anyway, let's just get into it rather than having me talk about this a ton. So, the first thing we're going to be talking about is we want to look at what a sequence of numbers is. Now, a sequence of numbers, and this is going to be something that you're going to have to really like focus on. It's a set of numbers that are written in a specific order that follow some sort of pattern. And basically, there are a finite amount of these numbers. Now, that seems a little bit weird, but when I look at it, for example, if I had the function a sub n, and instead of using f of n, generally we use a to say that we're talking about a sequence of numbers. And we won't spend a ton of time on sequences, just so you know, but they are the basis for everything else that we talk about from here on out. Let's say I had 1 over n, okay? And the n's are all of the numbers, so like 1, then 2, then 3, then 4. If we wanted to know the sequence of numbers that we're looking at here, what we would do is we would just take 1 and we would put that in for n, and that would be the first number in our sequence. And then the second number would be 2, then 3, then 4. And you can see it would go on forever, and that's what those 3 dots mean, is it continues to go on and on and on. And that is our sequence of numbers. Now, when we graph a sequence of numbers, and your calculator has a mode for this, although it's kind of stupid to use it because we can talk about why a little bit later, but when you graph a sequence of numbers, because you're only plugging in the integers into the function, if you will, what a sequence of numbers looks like is a bunch of dots that follow a pattern. And we do not connect those dots together. Because this is what we're getting, and I don't know exactly what this sequence is, but this is what we're getting as we plug in different numbers. We plug in 1, we plug in 2, and you can see that they follow this pattern. And you'll always be able to see the pattern, even if you don't know exactly like what the sequence equation is. So when you graph a sequence, that's what it looks like. So if I wanted to know the first 6 terms of this sequence, I would just say a sub 1. That would tell me that I'm plugging 1 in, and I would get 2, or 1 plus 1 is 2 over 1 is 2. Then I get a sub 2, and we just plug in 2, 3 over 2. Then a sub 3 would be 4 over 3, a sub 4. You can see this real quick. I know this is, all we're doing is we're plugging numbers in for n. So I'd get 6 over 5. And then a sub 6 would be 7 over 6. And we could keep finding more and more in that sequence if we wanted to. And we could write the sequence like this, 2 3/2, 4 thirds. And you really only have to write the numbers in a sequence until you can recognize what the pattern is. Okay, so that would be the first sequence, the first 6 terms in that sequence. Now what we have to talk about here is an idea that's really important, and that is what is known as convergence. When we talk about a sequence converging, what we notice is that as our sequence gets really far along, in other words, if we're plugging in really big numbers, we can see that what's happening is we are getting very, very close to a specific number. Now, there's not any one number that a sequence has to get close to in order for us to say that it converges. It just has to be a number. And that's what this bottom part is saying right here. Okay, we're just saying as I take infinity and I plug that into my sequence, so I want to know what the term that is way out there. When I want to know what that is, all I have to see is that going to be a number? And if it's going to be a number, then we say that our sequence is going to converge. If we get infinity, then we say that the sequence is going to diverge. So the way that we do that is the same way that we found basically the limit as n approaches infinity. Basically, again, this is saying that I'm looking for a horizontal asymptote. So when I do that, in this case, I would get 5 over 3. Notice that is a specific number. That is not infinity. So we would say that this sequence is bounded and it approaches 5 thirds. Okay, that's what it's really saying. As I get really far along, I don't know exactly what my graph is going to do around x equals 0, if you will. It's really n equals 0, but at x equals 0. But if I were to look at the graph way out there as it goes way far to the right, I would see that basically all of the values I'm looking at are really close to 5 thirds. Okay, so like, for example, this one, and again, this is just like we did when we did limits approaching infinity. Just because this is a sequence doesn't change what's happening here. I just compare the powers on top and bottom. So the power on top here, I can see the limit as n approaches infinity, so the infinite term, if you will, I take infinity, I plug it in, the power on top is bigger than the power on the bottom, so I get infinity. So I would say that this sequence does not converge, it diverges, or we can say that it's not bounded. And we're going to talk more about bounded in just a second. Okay? Now this one's a little bit tricky, and this is written a little bit differently, but this is basically saying I want to take all the numbers and plug them in, and I'm going to plug in what happens once I plug in infinity. Well, infinity is not a number, so if you think about this for a second, like if I plug in the first couple numbers, I plug in 1, I'm going to get -1. I plug in 2, I'm going to get +1. And it's going to go back and forth between -1 and +1. And although that's not getting really, really, really big, it's just going between -1 and +1, because it's bouncing between those two numbers and not approaching a specific number, we would also say that this sequence is divergent because it's not approaching a specific number. It's approaching two specific numbers, alternating between -1 and +1, but that is not what is going on in this sequence. Now, when we talk about a sequence being bounded, it basically means that there's some number that you're never going to reach, but it's going to be, you might get really, really close to it. That number is the bound that we're talking about. So if that number is like let's say our sequence is going up like this. The number that it's getting really close to, like here's the number it might be getting really, really close to. We would say that this sequence is bounded from above by that number. And vice versa, if we're looking at it below, we would say that the number is bounded below by that number. Okay, and again, hopefully that makes sense. It just means you're never going to reach that number, but you might get really, really close. Now, when we talk about something being monotonic, it just means that as our sequence progresses, you'll notice that the numbers don't alternate, getting bigger and smaller, bigger and smaller. They always, like this first one, is a monotonic sequence because the second term is bigger than the first term. The third term is bigger than the second term, and that happens in every single instance along the way in the sequence. And the reverse can be true. Like here's another sequence where 1/3 is smaller than 1. 1/9 is smaller than 1/3. 1/27 is smaller than 1/9. Those are both examples of monotonic sequences because you know that the term that comes next is either going to be larger or smaller than the term that came before it. So if I look at a monotonic bounded sequence, so I've got, and it could go in either direction, but let's just look at one that's bounded from above that is increasing. So there's my bounded monotonic sequence. Let's say it's bounded by that number right there. We can always say, if we have a bounded monotonic sequence, that sequence is going to converge on that number eventually. And that seems really easy at first. You're like, well, no, duh, but here's the part that's kind of hard to envision. Although it's getting closer and closer to that number, it will never actually be that number, but it will get so big that it eventually will act exactly like that number as we get our numbers in our sequence get very, very large. So it's not something that you need to bust your brain over, but realize that if I'm bounded, let's just say that I was bounded by y equals 1, and I've got this monotonic increasing sequence, so it's always increasing. And it's bounded by y equals 1. Eventually, my numbers in my sequence are going to be so close to 1 that they basically act like 1, but they're not going to be 1. Now, you can tell real quick, just like we talked about before, if a sequence is convergent or divergent, just by plugging in infinity. Like all I have to do every single time is the limit as n approaches infinity of whatever the sequence is. In other words, I'm just plugging infinity in. So I get 1 over infinity squared. That is 0. That is a number, so it's automatically convergent. On this one, like we looked at before, I plug in infinity on top and bottom. I get infinity, so this one would be divergent. The last one, sine of pi n, when I plug in infinity, now you have to remember the sine graph goes up and down and up and down and up and down. So if I'm plugging in numbers, I'm going to get dots along the way for my sequence that's going to represent the sequence, and it's going to continue to do that forever. That means that this series, I keep saying series, sorry, we're going to talk about those next. This sequence is going to be divergent as well. So this one was convergent, and it converges to 0 is what we say. The other two are divergent because they do not approach a specific number. This is the basis for, again, I know I kept saying series, and I tried really hard not to, but when we start talking about what's known as an infinite series, this idea of convergence or divergence is very important to understand. Because we need to understand that when we're talking about those two words, we're talking about either approaching a specific number or not approaching any number at all, any specific number. So hopefully that makes sense on what a sequence is and what we need to understand about them as far as convergence or divergence goes.